Hi, I'm Nora. I'm from Massachusetts and I go to Lexington High School.
Hi, my name is David from Virginia, and I go to Thomas Jefferson High School for Science and Technology.
Hi, my name is Audrey. I'm from California and I go to Miracosta High School.
Hi, I'm Aparna. I'm from New York City and I go to Bronx High School of Science.
Hi, I'm Rahman. I'm from New Jersey and I go to Manalapan High School.
And I'm Sam. I'm from Massachusetts, and I am the TA for AtTheRealShazam.
Here we demonstrate the capability of our program to load in any image from a file. Using FaceNet, we identify the faces in the image, then pass each face to our model to determine whether or not they are wearing a mask. The percentage of people wearing a mask is shown in the top left corner. We can then use facial landmarks, such as the position of the eyes or the nose, to estimate the approximate distance between the people. If it determines the distance to fall below the threshold of 6 feet, it represents this proximity with a red line.
Not only is our program able to identify the masked faces in an uploaded image, but it can also process an uploaded video. As you can see here, our program identifies the faces in the video, determines who is wearing a mask, and draws lines between the people who are too close together. All of this processing happens frame by frame as the video is played back for the user.
One eternity later.
As shown from the videos, we tested models to see how accurate they were able to detect faces with masks or without masks. Both models were constructed using a convolutional neural network with 2 convolutions, since this type of network tends to work better with classifying images. The first training plot was created using MyGrad, while the second was created using PyTorch, both AutoGrad libraries, with the latter being more optimized.
And now for our sponsor, Python Like You Mean It. Made by the one and only Ryan Soklasky, it is the best resource for learning Python, and it's completely free. Check it out today at pythonlikeyoumeanit.com.
While developing our project, we inevitably came across many failures and obstacles. The first major failure occurred when we tried to train our model for the first time. Because we were using a dense neural network instead of a convolutional neural network, and because we were only giving our model 40 pieces of data, the model was simply memorizing the data instead of actually learning how to make predictions. To fix part of this issue, we searched online for more data, where we found even more issues. Luckily, Google Translate helped us understand what data to download, and a quick search for the specific file type of the images allowed us to extract them from each folder without having to manually open each folder. However, even with our model fully trained, we ran into an issue with the pre-trained model we had been using. We had been allowing this pre-trained FaceNet model to identify an object as a face even with a very low confidence score, but setting a threshold for the confidence score prevented any more false positives. And finally, our most recent major hurdle was trying to get an uploaded video to be processed and played back simultaneously. As a result of the large amount of data that would be passed into our model if we left the video at its original size, we realized that we had to downsize any videos if we wanted the video to play back at the same speed.
When brainstorming ideas for this project, we came across other potential topics, such as music generation and email classification. Ultimately, we decided on mask and social distancing detection because of the significance of its modern-day applications in collecting information that could be useful in predicting the speed that coronavirus will spread in certain areas.
Hello again! It's us, Team AtTheRealShazam, and that was our week for our capstone project.
In the end, despite our many failures, syntax errors, and slow model training processes, we were able to produce the mask and social distancing detection program that you have seen in this video.
Not only that, but we were also able to create an easy-to-use user interface through our main.py file.
We hope you enjoyed seeing our development process and the results.
Thanks for watching.
Goodbye from Team AtTheRealShazam, and go CogWorks!
Oh, by the way, David, I moved the distance stuff out of main and into the display image functions because what I'm doing...
together. It's harmonious.
Am I doing it?
Yeah, you're all.